Yes, good morning, doctor. I am by the names of Bianca Joshua Aaron, and here to take you through network analysis and multivariate data analysis for the task that you assigned to us. I'll be using network analysis of airports and routes data is the data set I chose for this analysis. And the context here is basically to form a complex network that can be analyzed for connectivity, hubs, and traffic patterns. This analysis will aid to this analysis will help us understand airport density, which is basically the measure of airports per unit area, and also understand whether geography influences airport distribution in terms of latitude. So without further ado, let's go to tulip and do some analysis. So my data, I cleaned my data set uh, for some. So for the data cleaning, I used some bit of Python since the data set was huge and it had uh, a lot of misplaced values and empty fields. So I trimmed down the dataset to around 100 airports for this analysis. So to analyze this data, we can go ahead and create a new graph. So we can see clearly our graph right now is empty. I'll go on to the data was split into nodes and edges, where nodes has the metadata about the different airports that I'm going to use for this analysis, and the edges basically has information to do with so this is the nodes data that talks about the different airplanes, the name, the longitude, latitude, the region where they are located, and their airport density. Shall see that what it means. And we also have the edges data. This one basically has the connection between the different airports and the distance that is required for one to move from one airport to another. Just a minute to be loading. So it has this information. The source ID, the target ID basically shows from this airport with this ID to this intended destination, and the distance is 1500 1000 I mean 105 kilometers. So this is the information, the cleaned information of the edges dataset that we'll also be using. So when you go back to tulip, we shall import first our nodes. So I'll go and import my nodes. I'll use the existing relations between the nodes and I import my data. So basically this is how the data looks like. I'll go and also import the edges data, which is this. Here I'll use new relations so that I see my connections properly. So when I import, you can clearly see this node diagram here. So from this, we can clearly see there are some insights we can pick from this diagram. We can clearly see there is some bit of high connectivity, where we see almost every node is connected to multiple other nodes, indicating dense flight network. as we can see here. Then the presence of many edges suggests that most airports have multiple connectors. And for the peripheral nodes, what I mean, these nodes at the corners of the diagram, like 32 and 240, these ones we can clearly see they have like fewer connections. We can see they have fewer connections, possibly meaning these are more of regional airports. So we have also these central nodes here where there is a high dense fly network. Uh, these are likely to be hub airports with many connections. So these are some of the insights we can get. I got from this information here, from this network diagram here. We can further go ahead to understand how this flight network is distributed on like a map. So we shall go ahead and create a geographical view, and we can clearly see that this dense network, as we saw, these different airports like these ones from the Papua region, these ones here, Papua New Guinea region. You can see to get from this, there is of course they are connected to these other airports in Canada, in Europe, in Iceland, these different regions here. But you can clearly see that, of course, to get from this point to this point, of course, there are a lot of kilometers that a plane has to cover. So basically, this is to give you like a geographical representation of how these airports are distributed according to the different regions they exist in. So we can also do some further analysis to understand how remember we talked about, we want to understand how airport density and latitude, how they affect this entire flight network and airport distribution. So I'll create a parallel coordinated view for that task. So here I will select airport density. I'm interested in airport density, altitude, and the region. So I want to see how the different regions are affected by these two matrix. So we can see we have this diagram here, but for this we can let's say we are interested in understanding how these affect Iceland. So we can come here and say only airports and the network for Iceland. I can come here, say I'm interested in custom value here. I'll go back to my dataset. Allow me to open my dataset to make sure I copy the right spelling of Iceland. Now, if I search, you can clearly see now it has highlighted for me all all the flights in Iceland, all the different airports and their networks in Iceland, which is this in blue. From this, we can clearly see that Iceland has the highest airport density of around 0.097. Remember, I said airport density it's basically a measure of the number of airports per unit area. This basically tells us that Iceland's airports appear at, we can also see that when you look at the altitude, Iceland's airports appear at mid-range altitudes, likely due to its, we can say maybe its volcanic terrain. And we, from this diagram, we can clearly see that lower altitude regions tend to have higher airport density. And in conclusion, we can clearly see that from this diagram that geography influences airport distribution, where lower altitude regions generally have higher airport densities, likely due to easier construction and high demand for connectivity. And when you look at Canada, you can clearly see Canada airport density varies widely, reflecting a difference in population distribution and accessibility needs. So that those are some of the insights I drew from this data. Thank you for listening. That's it.